Hello everybody, and welcome to your video for 3.1.2 and 3.1.3. So what we are actually going to do for this section is we are going to combine these two together. The reason we're doing that is because they're both about similarity and ratios, and I think it's something that we can probably sum up pretty quickly in just one day. So that is our goal, is to combine those two lessons. So your video might be a little bit longer today, but just make sure you guys are taking notes and you guys are following along for this. Alrighty, so the very first thing, like always, is your joke. So what do you call friends who love math? Algebros. Alrighty. So yesterday, you guys learned all about dilations and making images bigger and like basically blowing them up or zooming them in. And so today we're going to talk about similarity and then the ratios behind the similarities. So the way that I like to think about similarity is when they are related by a series of transformations, including dilations, they are called similar. Similar figures have the same shape, but not necessarily the same size. Similar figures can be created by multiplying each side length by the same number. This number is called the zoom factor. So you'll hear me ask you guys a lot, hey, what's the zoom factor? What are you guys dilating it by? How are these images similar? You may have a zoom factor before when you were using, wait, no, that doesn't apply. So there's different types of things, like you guys can blow it up by like 50, or you can multiply it by 2. It's the same thing. You're blowing it up 50%, or you're multiplying it by 2. So there's different types of factors here. The way that I like to think about, a lot of kids get similar and congruent mixed up. Congruent is they are exactly the same. They are the same thing. Congruent, you are the same. So when you think about congruent, I want you to think about like twins. Okay? So twins, think about obviously identical twins. They are congruent. They are the same. They look the same. Sometimes they act the same. They're congruent. And then if you think about similar, the way that I like to think about it is me and my mom. We are not the same. But we are very similar. We teach the same way. We talk the same way. We have the same sarcastic demeanor behind us. So we are similar. We're not congruent. So similar meaning we have some of the same qualities, but we're not the same. Congruent meaning we have all of the same qualities. Alrighty. So this is actually one of the questions from the book. It is question 312, and we're just going to talk about the part B. So it says, what zoom factor was used to enlarge the puppy shown below? So what you want to think about is how you go from 5 to 15. And there's a lot of different ways we can write this. So to go from 5 to 15, we have to multiply by 3. So you're multiplying by 3 here for that. Now you just don't want to say, oh, it's 3. That's it. There's a couple different ways we can write it. We can write it as a ratio. So it's 3 to 1. So 3 would be the bigger image and 1 would be the smaller image. So it would kind of be like if you had a fraction, you were simplifying it. 5 over 15 would simplify down to 1 over 3. You can actually write it in as a fraction. So 15 over 5 or 5 over 15. So this is going to get us 3 over 1. Or 1 over 3. Okay, so there's another way you guys can write it. Or we can say we are blowing it up 300%. So you are making it larger by 300%. So a couple different ways we can write it. So you don't just want to say multiply it by 3. That's not mathematically correct. You either want to have a ratio or a fraction, or a percent. If you just sit here and have multiply by 3, we're like, okay, what are we multiplying by 3? What was the first thing? What was the second thing? You need to have some kind of statement here that says if something is 1, then the other relationship would be 3. So that would be the factor for that guy. Alrighty. Then moving on to our methods of meaning box. So this just talks more about ratio of similarity and the zoom factor again. So you can sit here and I would definitely write down the idea of ratio of similarity. So if you have a ratio of similarity here, that means you have to correspond the sides together. If you look at this right triangle, you guys should know that 6 and 10 are the hypotenuse of that triangle. So it's the hypotenuse. And since they're both the hypotenuse, we can compare those. We can look at those together. So the ratio of similarity of that would be 6 to 10, or you could say 3 to 5. You can see below they said 10 to 6 or 5 to 3. So those are our zoom factors and our ratios of similarity. So the hardest part about this is knowing what sides correspond to each other. So making sure that you're comparing the right sides and you're looking at the right ratios here. Alrighty. So for the review preview problem for this section, I just want to revisit this, especially since you guys have your Chapter 2 test coming up on Friday. So just make sure that we are understanding this and we remember our relationships and all of that fun stuff. So what I would suggest you doing is pausing the video and making sure that you go through this and then double checking your answers with my work. That would be your best bet. So for this one, I know that I can do 119 plus y equals 180. And I can do that because supplementary angles. So supplementary angles. So to solve for y, I'm going to take 180 minus 119. I'm going to get y equals 61. Then I know that I can set 5x plus 11 equal to 61. And you should be saying that because corresponding angles. So corresponding angles for that guy. Okay, so all I'm going to do is solve for x here. And I'm going to get x equals 10. So y is going to equal 61, x is going to equal 10, and that's because of supplementary angles and corresponding angles. You will definitely have a problem like this on your test. So make sure that you know all of your definitions, you know how to justify your answers, and make sure you guys are reading the entire instructions, because some people on their team test got points taken away because they didn't tell me why the angles were what they were, or why you found them. If you go back to your first section, a lot of people did not explain to me that it was supplementary, or they were triangle angle sum theorem, or their corresponding angles. Alright, so that wraps up section 3.1.2. So when you guys come in on Wednesday, I'll have what problems I want you to do on the board, but I'm going to have you guys do 315 from this section and 316 from this section. So only 2 problems. I think that they'll go pretty fast for you guys, so you can kind of see why we're combining the 2 together. Then if you go to 3.1.3, this gets more into the more practice and the more why we use it and how we use it. So this is the bigger section for us to focus in on. So 3.1.3 is using ratios of similarity. So now we're actually using them. We're not just discovering them. So how are the figures related? So we are going to talk about question 3-24 together, and then you guys are going to do 25, 26, 27, and 28 in class, along with those other 2 problems. So if we go to section 3.1.3, the first thing I want to talk about is just these rectangles here. So let's just make some observation and let's just talk about some stuff. The first thing that I want to talk about is which sides are corresponding. Now in this image, it's very easy to see here that 2 is going to correspond to 7, and that 6 is going to correspond to 21. Okay, but sometimes it's not that easy. You guys get a complicated figure. You get 2 triangles, one's turned a different way than the other triangle's turned, and it can get kind of confusing. So just make sure that you guys are being aware of that, and that your numbers are changing by the same factor each time. So we're looking at this and we say 2 over 7, and then 6 over 21. So we want to sit here and we want to look at the factor of this, or what's going on. So we're saying, how do we go from 2 to 6 and 7 to 21? And this kind of goes back to your giant ones. You guys should remember your giant ones from 7th grade, maybe a little bit in 8th grade, but your giant ones are telling you, hey, how are you going from 2 to 6 and 7 to 3? We're multiplying by a factor of 3. Okay, so our ratio for this is going to be 3 to 1, and all of that fun stuff. And I actually apologize for this. I don't know what I'm thinking of. 2 and 6 are in the same rectangle. So obviously you're not looking about how you're going from 2 to 6, you're looking about how you're going from 2 to 7. And like I said, I apologize. I have not drinking my coffee yet this morning. So you are sitting here saying for every 2, you have 7. So if you think about that, you're multiplying everything by 3.5. So how do you go from 2 to 7? You multiply by 3.5. How do you go from 6 to 21? You multiply by 3.5. So that is your scale factor, not 3 to 1. So when you guys are setting up your ratios, you want to look at what corresponds and not what's in the same rectangle. So learn from my mistakes. Do not do my mistakes. So 2 to 7 would actually be our ratio. So for every 2, you're given 7. Vice versa, for every 1, you're given 3.5. So lots of different ways you guys can look at this, okay? So if I was asking you to find, hey, how do you find that this missing side length right here? What's going on here? You would take 2 times 3.5 to get 7, and so you would do the same thing to 6. You'd multiply it by 3.5 to get you 21. So I apologize for that. All right, methods and meaning. So you guys are actually going to discover this idea throughout the lesson here, but proportional equations is one that compares 2 or more ratios. So proportional equations can be compared or can compare 2 parts of a corresponding parts or sides of similar shapes, or can compare 2 parts of one shape to the corresponding part of another shape. For example, the following equation can be written for a similar right triangle. So this is all just proportions. You guys have practiced proportions before. You guys know what proportions are. Lots of different ways you guys can solve them. I like the cross multiplication method, so on and so forth. So that's proportional equations. The other thing that you guys are going to talk about that is a super, super important concept is that just because the lengths of the sides are changing does not mean that the angles are changing. If the object is similar, the angles stay the same. So if the object is similar, the angles stay the same. So that's a really, really, really important concept, and I'm actually going to put that on your exit ticket tomorrow. So if objects are similar, the angles stay the same. Alrighty? Okay, so let's jump into some review preview problems here really quick, and then we'll finish up the video. So this person is working with a parallelogram drawn at the right, and she wants to make it smaller instead of bigger. What size should she do if she wants the sides of her new figure to be half as long as the original side? What zoom factor should she use for the dimensions of her new figure? So her zoom factor would be 1/2. Obviously, she wants to make it smaller. She wants to decrease the size by half, so it's going to be 1/2 or 0.5. Okay. While drawing some other shapes, she ended up with a shape congruent to the original parallelogram. What is the common ratio between the pairs of corresponding sides? So remember, if something's congruent, it is the exact same. So think about what number you can multiply those sides by to get the same exact number. So think about what can you multiply 11 by to get you 11? And it's going to be 1. So our ratio for that guy is going to be 1 to 1. Because you're multiplying both of them by 1 to get you the exact congruent object. So that's what makes this so difficult, is they're going to throw in congruent and similar together, and you're going to have to differentiate between the two of them. Let's go back here. I forgot to find the dimensions of the other figures. So my length here is going to be 8. And then my top here is going to be 5.5. So if you want to cut it in half, you just divide all the sides by 2. Divide by 2. Okay, here's some proportion work. So we're doing 2 of these now, and then you guys are going to have 2 of them to do on your exit ticket. So making sure that we understand this. You guys might have learned it lots of different ways. I really like the cross multiplication method. It's just the way that I learned. You could sit here and say, hey, 10 to get to 5, you're dividing by 2. So what can you divide by 2 to get you 11? So we know that m is going to equal 22. Another way you could do that is cross multiplication. So I'm going to take 10 times 11 equals 5m. And then our last step is to get m by itself. So we're going to divide by 5, and we get 22 still. So some of them are just easy enough that you can sit there and say, hey, how am I going from 10 to 5? Okay, I'm dividing by 2. It's always either multiplication or division for proportions. So if you're looking at m, how are you going? What would you divide by 2 to get 11? It's got to be 22. This one is a little bit more complicated. You got a little bit more work here. So what I'm going to do is I'm going to set up my cross multiplication here. So I have 3 times x plus 1 equals 5 times x. Now it's just an equation. You guys know how to solve equations. You guys all passed Algebra 1. So I'm going to start by distributing here, and I'm going to get 3x plus 3 equals 5x. I'm going to have 3x equals 2x after I subtract the 3x over. And then I'm going to divide by 2. So I'm going to have 3 over 2 equals x. So your x is going to equal to 1.5, or 3 over 2. Alrighty, so I know that was kind of a longer video, but we're going to kind of condense the 2 sections together, because I think that the first one you guys can pick up on pretty easily, and then the third section, 3.1.3, is kind of our bigger main ideas that we really want to focus in on. So come prepared to get started right away on Wednesday. You guys got a lot of problems to cover on Wednesday, and then you guys have an exit ticket as well. So just make sure you're prepared for that. Other than that, have a great night, and I will see you guys tomorrow in class.